This is Unit 6 review for Calculus BC. Problem number 1 asks what is the area of the shaded region? So to find the area, you need to draw a really small rectangle, and you're going to find the area of this rectangle. And we're basically going to add a bunch of small rectangles, so that means doing the integral. And I'm doing the integral from -2 to 2. And the area of the rectangle is the height times the base. The base is the small change in x. And the height is the top curve minus the bottom curve. And that should give you 19.2. Problem number 2 says, a curve is given by y equals quantity of 9 minus x to the 2/3 to the 3/2 from 1 to 8. What is the length of the curve? Remember the definition of length is going to be the integral from a to b of the square root of 1 plus y prime squared. So I'm going to have the integral from 1 to 8 of 1 plus my derivative. So since y is 9 minus x to the 2/3, my derivative is going to be the derivative of the outside So I'm going to subtract 1 times the derivative of the inside. So I'm going to get 3's will cancel out and the 2's will cancel out. So negative square root of 9 minus x to the 2/3 all over x to the 1/3. And don't forget we need to square that. So if I use my calculator, I should get 13.5. So number 3, an 8 feet by 20 feet rectangular plate is vertically submerged in water so that the 20 feet length is parallel to the bottom of the tank. So what that means is here at the bottom of the tank, the 20 feet is parallel. So it's going to be 20 by 8. This is submerged in water. So what we're going to do is we're going to take a strip and we're going to find how much pressure or how much force is on that strip. So if you remember, the force on this is going to be the density of the water times the depth times the height. So we're going to have the length of the strip, which would be the height. The length of the strip is 20. And this is dy. So that would be the area of the strip. If we put my coordinate axis on the bottom, we don't know where this is, so we're going to call this y. So the depth is going to be 8 minus y. And then I'm going to go from 0 to 8 because I'm doing vertical strips. I'm sorry, horizontal strips from 0 to 8. So number 4, we're going to evaluate cosine 3 to x and sine 4 to the x. So since 3 is odd, we're going to rewrite that as a cosine times the cosine squared. And then we're going to use cosine squared is 1 minus sine squared, my Pythagorean identity, and we're going to substitute that into cosine squared. Then we're going to distribute. So we're going to let u be sine of x for both of them. So therefore du is going to be cosine of x, or 1 over cosine of x. Du is equal to dx. So notice how the cosine of x are going to cancel for both terms. So I'm going to have the integral of u to the 4th du minus the integral of u to the 6th du. So this is going to be u to the 5th over 5 minus u to the 7 over 7 plus c. And u was sine. Number 5 is, what is the integral from x minus 5 over x? So just being able to, if you've given everything, if can you still solve this? So what we're going to do is we're going to separate and then take the derivative and the antiderivative. Okay, so number 6, to evaluate this integral, we're going to use partial fractions. So this is the same as 5 minus x. If I factor the denominator, I get 2x minus 1, x plus 1. So I'm going to rewrite this as a 2x minus 1 plus b x plus 1. Then I'm going to multiply everything by 2x minus 1 x plus 1. So this would cancel, and I'm left with 5 minus x. The 2x will cancel, and I'm left with a x plus 1. The x plus 1 will cancel. So here's an equation that I'm going to solve. So the first one is, I'm going to let x be negative 1, because that would make this go to 0. So I have 5 minus a negative 1 equals b. 2 times negative 1. This would be 6. This would be negative 3. So b is negative 2. So then I'm going to let x be negative a half. Because if x was negative a half, this would be 0. So I have 5 minus positive a half. Because 2 times 1 half is 1. 1 minus 1 is 0. So 5 minus 1 half is equal to a 1 half plus 1. And then the b is going to 0. So I have 4.5 is equal to 1.5. So a is 3. So now substituting these back, I can take the antiderivative, So I'm going to let u be 2x minus 1. So du would be 2 dx. So 1/2 du is equal to dx. So the 3/2, I can just write it in the front. And I'm going to have ln of u. For the second part, the 2 can go in the front. Don't forget our plus c. And you can also simplify this and compress it into one term. Number 7, we're also going to use partial fractions. The 1/3, I'm going to write it on the outside, so I don't have to worry about it until the very end. Since it's a square, this one's a little bit different. I have to write x minus 1 plus b x minus 1 squared. So now if I multiply everything by x minus 1 squared, I'm going to have 4x minus 2 is equal to a times x minus 1 plus b. So I'm going to let x be 1. So that would give me 4 minus 2 is equal to b, or b is equal to 2. And I'm going to let x be 0. I'm going to have negative 2 is equal to negative a plus 2. So a is equal to 4. Substituting those back. Remember, I have that 1/3 in the front. So I'm going to have 1/3 4 ln of x minus 1 plus 2 x minus 1 to the negative 1 times the negative 1. And then let's not forget our plus c.